Standard 5.3. Students will find sines and cosines of some difference and double angles with triangles. All right, let's consider our example here. We have a couple of givens, and we want to find the sine of A minus B. Now, if you look on your formula sheet, sine of A minus B is defined as the sine of A times the cosine of B minus the cosine of A times the sine of B. Looking at our given information, we know the cosine of A is negative 7 over 25. So let's replace cosine of A with negative 7 over 25. Notice there's a minus from the equation and a negative because that's the value of cosine of A. Cosine of B is 3/5. So let's replace cosine of B with 3/5. What remains to substitute is sine of A and sine of B. So what we're going to do is draw some triangles to find these values. Notice that angle A is between pi over 2 and pi, or between 90 and 180 degrees, which places angle A in quadrant 2. Doing a little sketch here in quadrant 2, we can drop to the x-axis and make a triangle. Cosine is defined as x over r, so the x, or the horizontal measurement, would be negative 7. The r is 25, and using Pythagorean theorem or Pythagorean triples, you know that the other side of the triangle is 24. So now from our picture, we can find sine of A. Sine is defined as y over r. Y is the vertical component of our triangle. R is the hypotenuse, so sine is 24 over 25. Similarly, let's find sine of B. So notice that B is between 3 pi over 2, which is 270 degrees, and 2 pi, which is 360. That places B in quadrant 4. So let's do another little sketch here, and we'll draw a radius out, draw up to the x-axis to create a triangle, and place B in our fourth quadrant. Cosine of B is defined as 3 over 5. Cosine is x over r, and so our x component, the horizontal piece, right, it's along the x-axis, is 3, and the r is 5. Using Pythagorean theorem or Pythagorean triples, the other side of our triangle is 4. However, because we're in the fourth quadrant, this would be a negative 4 here. Looking at our diagram now, we can identify the sine of B. Sine, again, is defined as y over r. Y is negative 4, r is 5. So now we have values for all 4 of our expressions here. Now we can just go ahead and multiply. So if we multiply the first 2 expressions together, 24 times 3 is 72. And 25 times 5 is 125. Bring down the minus, and we multiply these 2 negatives together. We get positive 28 over 125. Now all we have to do is subtract, and our answer is 44 over 125. And that's the value of sine of A minus B. Let's look at another example. So in this example, we're trying to find the cosine of 2A. Now if we look on our formula sheet, cosine of 2a has 3 definitions. Cosine of 2a is defined by any of these 3 formulas. So we can choose any of these 3 while we're working through this problem. They'll all have the same result. Let's pick the first one, and no particular reason why. So cosine of 2a we can define as cosine squared a minus sine squared a. Now what remains is to substitute our values. The cosine of A, if we go back to our original problem, the cosine of A is defined as negative 7 over 25. So let's replace cosine of A with negative 7 over 25. And in our formula, it's squared. Bring down the minus from the formula, and then we have sine of A squared. So going back to our diagram, sine of A, notice, was 24 over 25. We got that from drawing our triangle. So we're going to replace sine of A with 24 over 25, and again we're squaring it because that's part of our formula. Alright, now let's go ahead and do some arithmetic. So when we square the numerator. Any negative that gets squared is a positive, so our numerator is 49, our denominator is 625, and when we square 24 over 25, 24 squared is 576 over 625. Now we can subtract the numerators and we get negative 527 over 625 as our final answer. This was standard 5.3, finding sines and cosines of some difference in double angles with triangles.